So now in the course CCPS 209, I think BlueJ has reached the end of its life as far as this course is concerned. It used to be a great alternative to Eclipse and such, so getting the beginners to code right away so that they don't get the impression that they're like in a cockpit of a 747 and all kinds of buttons and such. But so these days we have a IntelliJ IDEA by the same guys who make PyCharm. Essentially those two are the same program for all practical purposes, just for different languages, so any knowledge that you have on one directly translates to the other. And this IntelliJ IDEA is these days so beginner friendly that starting the next semester, so BlueJ is gonna be gone. We thank BlueJ for its service, but it doesn't spark joy anymore. So we're now in this video, so I'll show you how to do the labs of this course in this IntelliJ IDEA. So now I have an IntelliJ IDEA here open, so it is my old labs directory, but I'm gonna do everything from scratch, just like a student would. So in the IntelliJ IDEA, well, I don't have the top menu here in the screen, but let's create a new project. Just create an empty one, so just like you would. So we're gonna be creating a Java project, and okay, giving a Java 15 here. So let's see how we create the project name. So where we make let's call it the CCPS 209 labs example project. So you're gonna be naming your lab project something else, but let's see what happens when I create a whole new project here. So old one should be going away, and so now I'm here in the labs example project. There isn't anything in the source code file yet, but then so how to create these labs. So the first thing is to go to this GitHub page, and so from this code button, so you can download everything here as a zip file. So what is a zip file you're gonna put in some place in your computer that you can then take these automated testers that I provide for each lab problem. So every time you start working on a lab problem, then you copy the tester into the project. So now in the we're gonna be looking at the labs specification. So at the moment of recording this video, November 25, so this document consists of 70 problems. So any 20 problems of your choice gives you the maximum lab points. So you can choose what you feel like. But let's start doing this plain old integers. So every lab is contains the link to what is the automated tester. So the lab has to pass this JUnit test that I provide. So there is explicit test cases there, and then there is a pseudo-random fuzz tester generating a whole bunch of random arguments for your methods and calculating the checksum of the results, and then the checksum, if the checksum of your calculated from the results of your method equals the checksum of the results calculated from my private model solution. So then your method and my private model solution, they're black box equivalent. So even if the code is different, so this way you can verify yourself whether your solution is equal to mine, so correct. I don't need to release you my model solution. So this way the students can interactively, so when they're working, they always know what is working and what is not. So what is lab specification? So each one of these, so what is the class that you have to create? So Python to Java 1, I apologize for this slightly 90s thing to use numerical 2 to stand for the word 2, but so here in this example project, so let's create a new Java class. So it's gonna be P2J1. So all these names always gotta be exactly like I say in the specification, because so this is not Hugworks. So this is Ryan. So for now, unless they rename it to Hugworks, but so that my automated testers are not magical, so they don't know where you write your things unless you write them correctly somewhere. So then what we're gonna be start doing. So the first thing, that the automated tester, so Python, when we did the same in the 109 is a lot more flexible, but so that we implement the dummy like stub versions of all these required methods. So there's gonna be this kind of method, and we could of course have it like a return 0, like just that it compiles. It doesn't work, of course, but even better one so is to throw new unsupported operation exception. So just fill in the method body like the immediately like I can't do this, like the method just say that I'm not even gonna try. So this in a control fashion, so tells the automated tester, so because so this kind of exception is thrown, so then the test automatically fails, you see when it happens. So then from this document, so all these methods that are required, so we're gonna do the same thing, and I'm sure that this kind of thing could be automated somehow, but that's I'm too old for that kind of things. So I should learn these things eventually, but of course not a big deal. So in this first lab, you notice that we got 4 problems to solve. So we got solve all 4 problems to get the points. So I've designed all these labs that the problems in there like are reasonable. So we got 4 methods to write. So falling power, so this is just a bit of a combinatorics and loops as explained. Every other, so given practice using arrays. So given an array, so create an array that has to every other element. Create a 2D zigzag array and then count inversions. I think this used to be a Python lab problem, but it's been since then replaced with a whole bunch of other things. So now we have a class, and it doesn't do anything, but at least it compiles. So now to this lab project, we're gonna be, let's create a new class in here. So you could either copy the class into this source code directory, or I'm gonna try if it's possible. So here I have this so p2 test.java. What happens if I drag it here? Is it gonna? Yeah, okay, you could just drag it in here. What is it now saying? All right, so now what it is saying, so when you start creating this new IntelliJ IDEA project, notice it's saying that there's an error, but so this error here, so is come on, red light, what are you thinking of? There's supposed to be a red light here that is gonna give us an error. And cannot resolve a symbol JUnit. So why aren't you IntelliJ IDEA? Okay, here is the here is the red light. It just took a moment. So notice so the fix is now so easy to this. So okay, start testing. So we just add JUnit 4 to class path. So all my JUnit tests are written in JUnit 4. So it's not the most recent way, but we just add it to the class path and will so it just all happens with like a one click, and notice everything is now hunky donkey. So this running this, so I have this now, so this lab, the file in which I'm gonna be writing the methods, and then I have this automated tester that I provide. So you never ever modify this automated tester. So if it doesn't compile, so after that JUnit 4, so you gotta make sure that, like for example, all your method names are correct. So let's rename this to every others. So this is perfectly fine, but notice what happens to the tester. So scrolling down, so IntelliJ IDEA shows with the different colors. So red means that it is definitely wrong. So now it's saying that there isn't a method every other because I misspelled it. So always gotta be careful that like all these names and every method signature, just copy paste it, like don't type it by hand. So that it's always the same. So now this how this works. So BlueJ was nice that this JUnit was like really integrated right away, so didn't even need to press the red light bulb. But you can, so this IntelliJ IDEA is clever enough that when you say run to something that doesn't have a main method, but like it's a JUnit test, so of course IntelliJ cleverly realizes that when you say run the test, it means like run all the tests. So now Now let's see what is gonna happen. So it's a bit of a compilation. Now, of course, every single method failed, and when there's a failure, so what is we got it through an unsupported operation exception as it should. So we have, but what the important thing is that this tester now compiles. So it is the class that you write, and then this tester that I provide, they're always together. So if the tester doesn't compile, so don't email me telling that I put a bad tester. So put it, make your this class first correct. So let's fill in one of these bodies now. So let's fill in this array one, because so the big thing at the beginning of this Java course is to look at arrays. So Python has lists, and then Java has ArrayList, which is the same as the Python list, which is the horrendous syntax. But so these primitive arrays, which are primitive in every sense of the word in Java. So we read the specification again. So what does the specification say that we should do? So let's do this every other. So given an integer array, create a new array that contains precisely the elements in the even-numbered position. So notice not the even elements, but those that are in the even position, and 0 is even the last time I checked. So given the array, so in the element in the position 0 is 5 should be there, and element in the position 2, 3, and the element in the position 3 is 2. So skipping all the elements in the odd-numbered position, and then creating an array, notice it gotta be the correct length, so there is like an extra little twist in there, so that this length gotta be exactly right, that there isn't like an extra 0 element in the end. So we do this wrong first, so then we can see the test failing. So every other, so we know we're gonna make the mistake right away. So let's the result array, let's just blithely assume that it's the length divided by 2. So that formula is wrong. But so then what do we do for each? This could be done in a couple different ways. So we could loop through the even positions of the original, and then each element copy to have the position there. But it might reveal, or we can also loop to the elements of the result, and then say that the element in that position in the result array, where is it coming from? It's coming from the position 2 times I from the original, and then we return the result in the end. So now we can notice you can run an individual test also. So this IntelliJ is clever enough so that like the tests. So here you can just run this one tester method. Like I don't wanna run all of them because I just wrote the one method in there. But let's say with the erroneous buggy interpretation. So let's run this test every other. Let's see what happens. So this is okay, and we failed. So at the first, so all these test methods. So if we take a peek, so the JUnit so defines this all kinds of like assertions, which are like the assertions in the Java language, but they don't crash the whole thing. So the test it just executes, and whenever it comes to this kind of like a hurdle that something is asserted, like for example that this B1 array 4217 is going to be equal to the result of this method call, so calling every other method for this array A1 in so-called static method, so you call it through the name of the class. So let's see what is the error here. So array length different. So in the case somewhere in the test line at the 45. Yeah, so the first test passed, but then at this point, so notice, so we have a 3-element array, and then the result was supposed to be a 2-element array. So always read this error. So expected length was 2, but the actual length was 1. So in this array equals comparison. So this gives us a clue that like our array length calculation is incorrect. So the expected length was 2, and the actual length was 1. So then realizing that like a good thing to think in small numbers, that like if there is 3 elements, so position 0, 1, 2, so we get 2 elements in the result, not just 1, but the 3 divided by 2 truncating down is 1, so it's 1, 2. So we gotta add, so we could put a if else in there, but we can also realize that So if the length is odd, then we can add 1, and if the length is even, so then we can add 0. So just add the length modulo 2, the r. Notice the IntelliJ highlighted there, there is no such variable. So whenever you see red in IntelliJ, like always, like the attention right there. So now we fix the thing, and so now this is saying that this is a test, but notice the previous failed, so this wasn't passing. So let's run it again and see what happens. Okay, it's compiling, and okay, this is now what you wanna see, just like in blue chase or the green check mark. So I run this one test, so it passed so all these claims that were made, and then so I always have this kind of pseudo random fuzz tester. So students always ask me what does it mean, so I better explain. So the pseudo-random numbers, so the random number generator in Java standard library is guaranteed that it's exactly the same in every environment, and because so integer arithmetic in Java is guaranteed to be exactly the same regardless of the environment. So for the same fixed seed, so not only does this always produce the same pseudo-random test cases in my machine, but also in your machine. So regardless, are you Mac, Unix, Linux, Windows, whatever you're using, makes no difference. So Java is designed that the integer arithmetic, and therefore everything that depends on the integer arithmetic is 100% portable. So then for the checksum calculation, so from the standard library, so we CRC32 should be good enough, because I don't think we need like a cryptographic strength in here. So in Python we had the SHA, so there in the library, so might as well use that. But so just generate the given number of test cases, so choose a random length. Usually I make these lengths like an increase, like here we just choose a random length and fill it, so create the array and fill it with the random number. So this RNG, so from the given seed is every single time gonna produce the exact same random numbers, and then we'll ask the method like what is the answer, and then so update so this checksum, so we can feed it integers. So we feed it the length of the result array, and then we loop to the elements and feed all the elements. So this we do, so the checksum over all these trials, and then in the end I'm gonna claim that, so there's the one last hurdle before the test passes, that it's gonna be that the checksum, the value calculated from your answers, so it's gonna be exactly the same as the checksum that is calculated from mine. So you never modify the tester. So this explicit cases are gonna help you to debug and verify your logic, and then this pseudo-random fuzz mass tester, so it serves two purposes. So that enough of these trials that your algorithm, if it's too slow, so then you're gonna be spending the day waiting. So all these are designed that they should be ending in a couple of seconds. Like if this takes like a minutes or hours, like that's just my way of nudging you to say that like your implementation, it may be correct, but so it's just a way too slow. So then passing the checksum, so that's the last line of the test. So once the test method reaches the end, so that automatically means success. So the test has to run through past all these hurdles that these assertions put there, and then reaching the end. So notice there is not any kind of a return success, but so the fact that the test method reaches the end without failing in any one of these hurdles, so that means that it's a success. Okay, let's do another one. So what are we gonna do? So let's do the falling power. So the falling power, and this can be now. So this is now to illustrate the fact that so this really important for Python is that in Java, so this primitive integer types, they will silent the overflow. And now that I say that the result should be a long, so you can believe that I made this fast tester, so that if you use int calculations, it's gonna overflow. So we could make an error. So result is gonna be 1 initially, anything to the 0, the falling power or any power is 1, and then we're gonna be looping through. So we're gonna be counting up to k, and what do we result equals the old result times n minus k, I think, and then we return the result. So now we can let's see if the test falling power, we can now run it and see what happens. Okay, so I made some kind of mistake in the logic. So let's say just that I didn't forget what this is asking. So falling power raised to this power, but then okay, so 10 to the power of 5, 10, 9, 8, 7, 6. Okay, what am I doing wrong? So result equals result times, so if k is 1, so then this should multiply n into it. What am I doing wrong here? Children, I feel embarrassed. Something silly that I'm not seeing. So if k is 0, this is gonna terminate right away and gives the right answer. Okay, so what is that at the line 15? So 10 to the 3 is 720, and I return 343. Both of these numbers look very combinatorial somehow, but so what am I doing wrong here? What if I multiply it by n and decrement n every time? Let's see. I don't see why that would make a difference, but so something really simple that I'm. Yeah, oh, that did it. So why was it different now? N minus I. That's simple. Oh my goodness, I'm so silly. Yeah, that's the thing. But you see how blind I am to obvious things. So that's why I don't wanna test things on my own. So you want to have this automated test, and of course, so the important thing is that you get to. So any lab that you do, so here, so from this, all the tests are here. So you just put the test in your project, and then the tester is gonna be doing all the good things. So now, of course, there could be an error also in the tester, but that's why. So one last thing. So we have this bounty here. So bug bounty. So just to make sure that my testers are correct. So I have this list in here that all problems that weren't solved at the time I started the bug bounty list. So as you can see, there is still a couple that nobody has done for some reason. I wish so. You get so now all these problems like for minus or whatever in here. So that this student provided a solution, so that passed the test, so they like as a proof that it is possible to pass my test. So it's been many times happened that I had some bug in my private model solution, and then it was impossible to pass the test. So then if you reveal that kind of bug, so then I'll give even extra bonus for that one. But so this is how you use IntelliJ IDEA in this course. So there's a whole bunch of good things in the IntelliJ IDEA, like all kinds of refactoring and analysis and similar. So this, if you look at the very simple use is simple, and then you can look up tutorial videos and documentation for other things. So this is the IntelliJ IDEA. We are now in the current decade. So BlueJ we don't use anymore. So this is how you're gonna be doing the labs.